For thousands of years, people have looked up into the night sky and seen something absolutely remarkable. These incredible curtains of light just dancing in the darkness. They've been seen as spirits or omens, maybe even messages from gods. But what's the real science behind this amazing natural show? Well, let's trace its journey, all the way from the sun right to our own sky.
Just picture it. You're standing somewhere cold, far away from any city lights. The sky above you is just this deep, perfect black, filled with stars. And then, something starts to happen. A faint glow appears on the horizon, and it just keeps getting brighter.
Before you know it, that glow has turned into these huge, shimmering curtains of green light that ripple and twist across the entire sky. You can totally see why ancient cultures might have thought these were mythical beings. The truth, though, is all about physics, a kind of physics that connects us directly to the star at the very center of our solar system.
So here's the big question, right? How does this happen? This incredible light show that we see here on Earth, it doesn't actually start in our atmosphere. Its journey begins 150 million kilometers away, on the surface of the sun. To really get the aurora, we have to follow that whole journey.
Okay, so let's start with a really clear definition. The official scientific name for the northern lights is the aurora borealis. And what it is a luminous, completely natural display that happens way up high in our planet's atmosphere.
Now, here is the most important part to understand. It's not actually light that travels all the way from the sun. No, it's energetic particles that make that journey. And when these particles finally reach Earth and collide with the atoms in our own atmosphere, those atoms get energized, and then they release that energy as the light we see.
And this light isn't just some boring glow. The aurora shows up in these absolutely breathtaking forms. It can look like giant hanging curtains, or maybe gentle arcs that stretch from one horizon to the other. Sometimes it even looks like fast-moving waves and ribbons of light that seem to be dancing across the sky. All right, to really understand how this all works, we've got to go back to the source. The whole process is kicked off by the sun itself. You see, the sun is constantly sending a stream of energy and particles out into space.
And that stream has a name, the solar wind. The sun's outer atmosphere, which is called the corona, is unbelievably hot. We're talking over 1,000,000 degrees Celsius. That intense heat gives tiny particles enough energy to escape the sun's gravity and just flow outward in every direction, creating this constant wind that fills up our whole solar system.
And these particles are moving at unbelievable speeds. We're talking between 400 and 800 kilometers per second. At that speed, the solar wind only takes a few days to make that long journey from the sun all the way to our planet.
Now you might be thinking a constant barrage of high-energy particles sounds, well, pretty dangerous. And you'd be right. But luckily for us, our planet has its own defense mechanism, a kind of invisible shield that's generated deep within its core. This shield is called the magnetosphere. It's this huge magnetic field that surrounds our planet. And what it does is it deflects most of the solar wind, forcing all those particles to flow around Earth. A great way to picture it is like water in a river flowing around a big rock. Because of this shield, most of the solar wind never even touches our atmosphere. But some particles do get trapped by this magnetic field. And because the field lines all come together at the north and south poles, these trapped particles get guided or sort of funneled along these lines right toward the polar regions. And that's it. That is the simple reason why we usually only see auroras in the far north and the far south.
Okay, now for the grand finale. Those solar particles, after traveling all the way across the solar system and getting guided by Earth's magnetic field, they finally arrive at their destination, our upper atmosphere. This is where the light is actually born.
The physics behind this is actually pretty elegant. You have a solar particle flying in at an incredible speed. It slams into a gas atom in our atmosphere, usually oxygen or nitrogen. This crash transfers energy to the gas atom, and it gets put into what scientists call an excited state. But that state isn't stable. To get back to normal, the atom has to release that extra energy. And it does that by emitting a tiny particle of light called a photon. Now, multiply that process by billions upon billions, and you get the shimmering curtains of the aurora.
This also perfectly explains why we see different colors. The color of the light all depends on which gas is being hit and at what altitude. When solar particles hit oxygen atoms between 100 and 200 kilometers up, we see the most common color, that brilliant green. If it happens higher up, above 200 kilometers, oxygen collisions create a much rarer red glow. And nitrogen atoms, well, they add the shades of blue and purple, usually right at the lower edges of the aurora.
So even though it's one of the most beautiful things you can ever see, the aurora is much more than just a light show. It's actually a visible sign of the constant interaction between the sun and the Earth, something we call space weather.
You see, the same solar energy that makes those beautiful lights can, during really intense solar storms, cause real problems for our technology. These storms can damage satellites in orbit, they can disrupt GPS and radio signals that we depend on, and they can even overload electrical power grids on the ground. For example, a huge solar storm back in 1989 caused a massive blackout all across Quebec in Canada.
So as we wrap this up, it helps to think about the aurora in a new way. It's not just a pretty thing in the atmosphere, it's a celestial event. It's the beautiful result of our planet's own essential defense system doing its job.
Think about it like this. Every single time those lights flicker and dance across the sky, what you're really seeing is the boundary line, the place where our world meets the rest of the solar system.
You are literally watching the visible edge of an invisible magnetic shield, a shield that quietly protects every living thing on Earth by taking a potentially dangerous stream of solar radiation and turning it into one of the most beautiful sights in all of nature.
It really leaves you with a thought, doesn't it? The aurora makes a powerful hidden force visible to all of us. So the next time you look up, maybe just consider this. What other invisible forces, like gravity or magnetism, are quietly and constantly shaping our world in ways we can't always see?